What's up everyone? Welcome back to my YouTube channel. This is Caesar's Lab. Now to get started with the project playlist, I will be building a robotic arm. Now there's a particular reason for choosing this project, but I will tell you just now. So now let's get started with the roadmap to building this project. So I will first start by designing the model on SolidWorks. So I will model all the parts using SolidWorks and then making an assembly also using SolidWorks. After that, I will save the parts as STL files so that I can slice and prepare for 3D printing. I will then go ahead and 3D print all the parts. After that, it will be time for integrating the electronics. So I will need a few electronics for this project, including a servo motor, a programming board, jumper wires, a motor controller, etc. At the end, I will program the robotic arm using Arduino. And then we will play around with the robotic arm and see how it works. As for the timeline for this project, I think I will spend about 2 to 3 hours a week on this project. So it should take about a month or so, right? So I will try to upload a video for the progress of this project every week, just to keep you guys updated. So for the reason why I chose this project, so it was my very first design project when I got to university. So during my first year, we were given this project, which was to design a robotic arm on SolidWorks. Well, I did not have any experience with CAD modeling at that time. So as you can imagine, it was not really good looking. So there were a few problems with my design. So firstly, the structural integrity of this design was just bad. Okay, this thing would not pick up anything if it was built. Okay, the structures were not supported properly, the span, etc. Okay, the next thing is the assembly. The assembly, I was really bad with my assembly. I only knew how to make surfaces. So yeah, and then the placement of the servo motors, it was bad. Okay, but yeah, let's get into this video.
Okay, so what I did is to download my servo motors from GrabCAD, because those are your COT components. So yeah, I didn't want to waste time designing them. And we're getting started now. Choose a plane and then start your 2D sketch. Remember, 2D sketch, you draw it from the origin, and then we apply a shell that will hollow out the cylinder. Okay, so now I'm designing the legs so that the base is stable. So I'm only going to design one leg, and then for the other 3 I will just create a pattern. Those will be automatically generated. Remember, always save your parts. Okay, so now I'm exporting the part to an assembly environment. Remember, this is an iterative approach, so I'll be changing dimensions on the fly. So I didn't start the project with specific dimensions, so I'll be making changes as we go. Right now I'm basically being guided by the size of the servo motor. And the other factor is that I am not planning on including my power supply in the base. So my power supply would probably be outside, and then I'm only going to run wires into the base. That might change later though. Okay, so right there I was measuring the size of the servo motor so that I can design a stand for it. So it's gonna mount the servo motor, making sure that it doesn't move around in the base. So again, designing the mount, I am not sure yet where it's going to be positioned, but what I'm doing is to find the general area and then go back to the assembly environment and see where it is in relation to the servo motor. Okay, so from here I can see by what kind of changes I need to do. So the evaluating feature where you are able to measure, I find that tool very useful in cases of uncertainty and making sure that my dimensions, each part matches with the other one. So I just use the evaluate feature, measure one part, and then go back to the drawing board using those dimensions. Okay, so here I'm drawing the mounting holes. So I drew only one side, then for the other side I just mirrored. So in these videos I will not be explaining too much of SolidWorks. I'll just be focusing on designing the project itself. If you want details on how I did some of the features, just go to the SolidWorks playlist where I teach those basics. This right here will be the opening for the wires. power supply wires, etc. And the Arduino board wires. So I might change later and put the Arduino board inside, but we'll see. Okay, so here I'll be using a round servo horn. So I will mount a spinning platform on to the servo horn so that when the motor is spinning, it spins along with the platform. That will be our first degree of freedom for the robotic hand. So again, I'm using the circular pattern. So I find these very useful. It saves you a lot of time. Okay. Then I mating the spinning platform to the servo horn. Go. Looks about right. Now let's work with the evaluate feature to make sure that this platform perfectly fits onto the servo horn. So I'm just making here countersunk holes. SolidWorks has a feature to just automatically do countersunks, but we'll see that in another video. Okay, this is the basic structure of the base. What's left is maybe to kind of beautify it, make sure that it looks somewhat sexy. And we might include other features on a future video or towards the end, but this is the basic structure. Okay, I'll see you in another video. Do subscribe, like, comment. Yeah, cheers.